Hello friends, welcome to C++ programming video tutorials series. From the past few video tutorials, we are trying to understand operators in C++. We understood arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, conditional operator. In the next video tutorial, we understand bitwise operators. Before we proceed and understand bitwise operators, first we need to understand decimal number system and binary number system, guys. We have to understand how to convert a decimal number to binary equivalent number. We have to understand how to convert binary number to a decimal equivalent number, guys. So let's get started. Deci means 10, guys. In decimal number system, we have 10 digits. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. To represent any number in decimal number system, we take help of these digits, guys. For example, to represent 65, in the first place we write 5. In the 10th place we write 6. To represent 128, in the first place we write 8. In the 10th place we write 2. In the 100th place we write 1, guys. Whereas in binary number system we have 2 digits, guys. Bi means 2. In binary number system we have 2 digits. They are 0 and 1. To represent any number in binary number system, we write sequence of zeros and ones. To represent any number in binary number system, we write sequence of zeros and ones. Here, if the computer is an 8-bit computer, then 01000001 indicates 65 in binary number system, guys. 00001111 indicates 15 in binary number system, guys. If I ask you, tell me what this sequence of zeros and ones indicates. Of course, it is difficult for us to say, right? So we need to understand how to convert a decimal number to binary and binary to a decimal, guys. First we understand how to convert a decimal number to binary equivalent number. Take an example of 65. We have to divide the given number by 2. 2 into 32 is 64, remainder is 1. 2 into 16 is 32, remainder is 0. 2 into 8 is 16, remainder 0. 2 into 4 is 8, remainder 0. 2 into 2 is 4, remainder 0. 2 into 1 is 2, remainder 0. Once we get 1 or 0 at the end, we stop further execution. Then we write these zeros and ones from top to down, right to left, guys. So 1, 1, 2, 3, 4, 5 zeros and 1. This indicates 65 in binary number system, guys. If computer is an 8-bit computer, then we add one extra 0 here so that there will be total 8 bits. 1, 2, 3, 4, 5, 6, 7, 8, guys. Okay. Let's take another example. If I say 15, we divide this number by 2. 2 into 7 is 14, remainder is 1. 2 into 3 is 6, remainder is 1. 2 into 1 is 2, remainder is 1. Once we get 1 or 0 at the end, we stop further execution and then we write these digits from right to left. 1, 1, 1, 1. If computer is an 8-bit computer, then we add here 4 zeros, guys. So this indicates 15 in binary number system. This is how we convert any decimal number to binary equivalent number, guys. This is how we convert any decimal number to binary equivalent number, guys. I suggest you to try converting 35 to binary equivalent number, try converting 40 to binary equivalent number, etc., guys. Now we understand how to convert a binary number to decimal equivalent number. Already I told you that 1000001 indicates 65, right? So let's convert this series to decimal equivalent number. I open the MS Paint. Here I write the sequence of zeros and ones. So 1, 1, 2, 3, 4, 5 zeros and 1. What we do is we write 1, that is we start from the rightmost digit 1 multiplied by 2 to the power 0. We start with 2 to the power 0, guys, plus 0 multiplied by 2 to the power 1 plus 0 multiplied by 2 to the power 2 plus 0 multiplied by 2 to the power 3 plus 0 multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power 5 plus 1 multiplied by 2 to the power 6. Next, 1 multiplied by 2 to the power 6. You can see here 2 to the power 6 is equal to 64, guys. So 64 plus 0 multiplied by anything is 0 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 plus 1 multiplied by 2 to the power 0 is 1. Anything is raised to the power of 0 is 1, guys. 64 into 1 is 64 plus, so this complete thing is 0 plus 1 multiplied by 1 is 1. 64 plus 1 is 65, guys. So that is how we convert a binary number to decimal equivalent number, guys. Let's take another example. If I say here 1111, after the leftmost 1, if you have any zeros, they can be discarded, guys. There is no value of the zeros before the leftmost 1, guys. Okay, so that's the reason I'm not writing 000 here. Now let's convert this binary number to decimal equivalent number. So what we do, we start from the rightmost digit. So 1 multiplied by 2 to the power 0 plus 1 multiplied by 2 to the power 1 plus 1 multiplied by 2 to the power 2 plus 1 multiplied by 2 to the power 3. Like that we write 1 multiplied by 2 to the power 3 is 8 plus 1 multiplied by 2 to the power 2 is 4 plus 1 multiplied by 2 to the power 1 is 2 plus 1 multiplied by 2 to the power 0 is 1. Anything is raised to the power of 0 is 1. 8 into 1 is 8 plus 4 into 1 is 4 plus 2 into 1 is 2 plus 1 into 1 is 1. 8 plus 2 is 10. 10 plus 4 is 14. 14 plus 1 is 15. So 1111 indicates 15. So that is how we convert a binary number to decimal equivalent number, guys. I suggest you to try other numbers. These numbers you try, guys. So we understood how to convert a decimal number to binary equivalent number, how to convert a binary number to decimal equivalent number. There is one more way we have to convert decimal number to binary equivalent number, binary number to decimal equivalent number. For that, we need to remember 2 to the power series, guys. You can see I have written 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2 and so on up to 2 raised to the power of 7 I have written, because the maximum number I have to convert is 128. 2 raised to the power of 7 is 128, so I stopped writing at 2 raised to the power of 7, guys. If you have any higher number more than 128, maybe you need to write 2 raised to the power of 8, 2 raised to the power of 9 and so on. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4 and so on. 2 to the power 7 is 128. So we have 1, 2, 4, 8, 16, 32, 64 and 128. Here I have the example numbers to convert. First we have 65. How do we convert the 65 to binary equivalent number? We find out the numbers. On adding them, we should get 65. If I add 64 with 1, we get 65. So underneath 64 we write 1, underneath 1 we write 1, remaining places we put zeros, guys. So 100 0001 indicates 65 guys. If it is a 8-bit computer, then we add extra 0 here. Let's convert 15 to binary equivalent number. On adding 8 plus 4 plus 2 plus 1, we get 15 because 8 plus 2 is 10, 10 plus 4 is 14, 14 plus 1 is 15. So underneath 8 we write 1, underneath 4 we write 1, underneath 2 we write 1, underneath 1 we write 1 guys. And remaining places we put zeros if it is a 8-bit computer here. So we got 00001111, that indicates 15. Let's convert 35 to binary equivalent number. Very easy. Let's find the numbers. On adding them, we should get 35. So 32 plus 2 is 34. 34 plus 1 is 35. So underneath 32 we write 1. Underneath 2 we write 1. Underneath 1 we write 1. And the remaining places we put zeros guys. So 1000011 indicates 35. To convert 40, we find out the numbers. On adding them, we should get 40 guys. 32 plus 8, we get 40. So underneath 32 we write 1. Underneath 8 we write 1. Remaining places we put zeros. Right? So 1010000 indicates 40 guys. 128. Underneath 128 we write 1. Remaining places we put zeros. So 1000000 indicates 128 guys. And remember that zeros before the leftmost one, okay, zeros before the leftmost one can be discarded. Okay. Now we understood how to convert decimal number to binary equivalent number. Let's understand how to convert binary number to decimal equivalent number. Again we write same 2 to the power series 1, 2, 4, 8, 16, 32, 64, 128. And here we have example binary numbers. What we do? We just write these numbers from right to left. So 1 is written, then we have 5 zeros, so 0, 0, 0, 0, 0, and then 1 and then 0. We find the numbers above 1 and add them. So above 1 we have 64, above this one we have 1. So 64 plus 1 is 65 guys. So this number indicates 65. This sequence of zeros and ones indicates 65. Same thing I have written here 1 1 1 1 0 0 0 0, right? Let's find the numbers above 1. We have 8, 4, 2, 1, right? Above this one we have 4, above this one we have 2, above this one we have 1. So on adding 8, 4, 2, 1 we get 15 guys. Simple. We converted binary number to decimal number. Now you can see I have written 0 0, then 1, then 3 zeros, 1 2 3, 3 zeros and then 1 1. Let's find the numbers above 1. Above this one we have 32, above this one we have 2, above this one we have 1. So 32 plus 2 is 34, 34 plus 1 is 35. So 0 0 1 0 0 0 1 1 indicates 35. Like that we convert any binary number to decimal equivalent number guys. I hope you guys have clearly understood how to convert decimal number to binary equivalent number and how to convert binary number to decimal equivalent number guys. If I go here, let me say Control A and delete. If I write here 2 to the power series 1, 2, 4, 8, 16 like that, we can represent any number in binary guys. For example, if I have to represent 1, underneath 1 I write 1. To represent 2, underneath 2 I write 1, underneath 1 I write 0 guys. So 1 0 indicates 2. To represent 3, underneath 2 I write 1, underneath 1 I write 1, because 2 plus 1 is 3. So 1 1 indicates 3. To represent 4, underneath 4 I write 1, and underneath 2 I write 0, underneath 1 I write 0. To represent 5, underneath 4 I write 1, underneath 2 I write 0, underneath 1 I write 1, because 4 plus 1 is 5 guys. If I have to represent 6, Underneath 4 I write 1, underneath 2 I write 1, underneath 1 I write 0 because 4 plus 2 is 6. Like that we can represent any decimal number in binary by remembering this 2 to the power series, guys. That's it, guys, for this video tutorial. I hope you guys have clearly understood. In the next video tutorial, we'll understand bitwise operators. If you understood whatever we discussed in this class, then definitely you can easily understand bitwise operators in the next video, guys. So see you in the next video. If you like this video, hit the like button and share with your friends so that everyone will get benefited. For more benefits and be up to date, do not forget to subscribe to our YouTube channel. Keep learning, keep coding, keep sharing. Thank you, guys. Thank you very much. See you in the next tutorial.